set the stage. So again, most of you should be interested in simulation in general. So we're going to talk about, digital twin. Now, very much a buzzword. I'm a very pragmatic, practical guy. So I'll try to, interpret it and set the stage in that fashion. So we all have a good understanding of what it is we're trying to achieve. And then, and Justin talked about the portfolio. So we're talking about simulation tools. But how do you use these simulation tools in an effective fashion for your company and get maximum value out of it? So this presentation, will explain what that digital twin means from a simulation standpoint, and my colleague René is going to come up and give some practical examples. And that's going to be an underlying theme for the day is, yes, we have some great tools. Yes, you can do lots of great things about it, but we want to share practical experience with you. We want to establish a partnership with you. We want to say, at the end of the day, you want to implement this CFD method, this FEA method in your companies and get maximum value out of it. We're the partner for that. So that's really the goal for today. So here's who I am. Very serious. Simulation is a very serious thing. So bad picture, sorry. Look like a deer in headlights. But in any case, I'm in charge of our European and UK operations. I've been with Maya for 14 years. I'm a former CFD guy. Again, they put some funny numbers up there, 20,000 hours. That's a big number. Doing business in the UK for more than 12 years now, led me to a lot of air miles and flights and whatnot. But the gist of it is we are an international company. We have customers all over the world. That collaboration and partnership with Siemens is great for us. It exposes us to great customers like you. And we're really always thriving and looking for more new applications and more new collaborations. And I'm also a sports coach, so ice hockey, you'll hear more about it later, very Canadian. So as you see with the accent, and furthermore, American football, and your proper football as well, but that's another story. So the digital twin, first of all, let's just set this stage here. I'm just gonna do a little activity to, keep it lively. So just raise your hand if you have a smartphone, own and operate a smartphone. Everybody in the room, so bingo. Just keep your hands up, okay? Just keep your hands up. And what I'll do is I'll do a roll call. Any technology that I list out that you still use, put your hand down. You still use a paper, diary, or agenda? Do you? If you don't, you need to put your hand down. Okay, a bit of a reverse. If you still use an alarm clock, who uses an alarm clock? Put your hand down. A calculator, a proper calculator, put your hand down. Traditional mail, snail mail? No, yes? Radio? And you kind of get the point. This little pictorial here just pictures and sets the stage for digitalization. It really transforms the way we do things. I grew up with an alarm clock, waking up and mom telling me to write stuff in the diary to make sure I wouldn't miss a class or whatnot. But it really sets the stage for what we're talking about here is digitalization. And in a few minutes you'll see what it all means from our perspective for engineering proper. But from a global business point of view, the founder of Dell, Michael Dell, was saying that the next $1 trillion, sounds like an Austin Power movie, will all come from data for our customers and for our industries. I was attending a Daimler conference not too long ago, and they were using the image that data is the new oil. Very powerful message, very, very powerful message. And Accenture, and then just the general trend in the industry, half of the Fortune 500 companies have disappeared and have been replaced since the last 20 years or so. And a big driver of that and behind that is the digitalization. So to bring that back into context and towards Industry 4.0, and again, being pragmatic and practical about it, the introduction of steam engines and whatnot, the ability to set production lines. We heard they're talking about a slaughterhouse, but that eventually transpired to automotive and a lot of other industries, and going to the third industrial revolution, introduction of robotics, mechatronics, and whatnot. And we're really going through this fourth industrial transformation, which is all about establishing an Internet of Things, which is all about connectivity, which is all about digitalization, the cell phone example I gave a few minutes ago. So what does it mean for us? Again, trying to be pragmatic about it. Most of us are engineers, most of us are working in design or analysis functions. So what we're talking about here is creating this digital twin concept. So really having the ability to have a digital representation of our product. the ability to connect that to the manufacturing side of things. So I'm realizing my product and I keep a connectivity to my digital representation. And going all the way into in-flight and operation in service mode with real-life products that all have their particularities, but being able to connect that to the original digital twin that you've used to design it. So one of the key messages and one of the key enablers with the Siemens portfolio, but also with the key ingredients that René will be talking about, is getting maximum value out of that digital twin and going through that third industrial revolution. So I'll give an example. I'll give it a really practical example. I like this graphic, so just end with a digital twin example. So let's say I'm a truck maker. I have a requirement coming in from marketing that is really key to my business. And I need to extend the range of my truck because all competitors are able to operate with larger ranges. They don't have to refuel as much in this business, so obviously they're getting a lot more business success from that perspective. And I want to use digital tools and the digital twin to rapidly evaluate how to best solve that problem. I'll show you how to do that. So what we're doing is we're effectively leveraging digitalization to rapidly evaluate all the impacts of that new requirement. And here you have the digital representation, the digital twin. Love this pictorial. And what we're really focusing on is modifying the size of the fuel tank. So I could, to increase the range, look at a new engine, be more efficient from that standpoint. But that's not really a practical solution in my example. So I'll just take a very engineering view of the problem and just increase the size of the fuel tank. So with the digital tools and the digital twin, I'm able to rapidly change that core requirement for the fuel tank capacity. So moving it from a capacity of 60 gallons to 95 gallons in this case. And quickly, within the PLM framework, establish and evaluate what gets affected by this change in requirements. So with some pre-built workflows and pre-built checkpoints on performance, I'm able to see that change in requirement trickled down all the way into some of my performance validation points, and I got a notification that the actual brackets that were holding up the gas tank were effectively failing under that increased weight. So taking the concept further, that value of digital twin, and you're going to see that it applies to the design task, the production tasks, and all the in-service tasks as well. But I'm able to use PLM tools to rapidly detect any components around the fuel tank that may be affected by that increased capacity, by that change in size. So the brackets will need to change, but also I'll need to move some fuel lines around. So that's what I can achieve with my design tools. So move some brackets around, basically rebuild the concept, move the fuel lines around, and then use the simulation tools to rapidly evaluate what the new performance is, any modal problems I may have in actual road profiles, any failure and durability problems I may have. And further down the road, once I've designed, validated my new gas tank, my new attachment mechanisms, I'm able to send that off to purchasing to basically get existing parts using shape searching tools and whatnot. So you kind of get a view for the value and the continuity of that digital thread using the digital twin representation of my problem. So what we're effectively promoting is removing barriers between ideation, realization, and utilization. So back to the simulation world, and I'm going to end with this slide, is what does that really mean from a simulation perspective, building a digital twin? Well, there's three major elements to achieving a digital twin successfully from a simulation point of view. First of all, you want to be able to build a realistic representation of your product. So have very simple representations, simple models, system level views, and be able to scale the representation, the granularity of the model. So those are things we offer with the portfolio and also with best practices. Another way to look at the realism aspect is to look at different physics from the same environment. So not only focus on structural problems, classical problems, but go into high-end CFD, go into system-level representations, durability, motion, and whatnot. You also want to keep traceability into your simulation models. So that continuity aspect is key. Again, those of you who are, analysts, we've always had that problem where we run a model, we run a simulation, it goes off on a hard disk somewhere, and I wouldn't say it's lost, but if you look for it 6 months later, good luck finding it. And it's not bad will, it's not bad intent, but we just generate massive quantities of data. So being directly integrated in a market-leading PLM system gives us a platform to manage that information in a smarter fashion than hard disks, right? So that's effectively what we promote. And René will talk about some examples of that. So, and ensuring that there's traceability, ensuring that there's an ability to go back and find the relevant simulation models. You wouldn't believe how many high-end customers still have that problem, and we're trying to help them build better practices. And it doesn't have to be the big global big bang transformation. You can achieve this in gradual steps, and that's what we're going to be talking about today in how you realize the digital twin, how do you implement it in a successful fashion. And finally, the last point in building a successful digital twin from a simulation standpoint is doing so not only in an ad hoc model by model, simulation by simulation fashion. It's also utilizing the tools to build automated workflows. So René will give you some practical examples on that. SimCenter, CD Adapco, Star CCM Plus offer us a great platform to do that, and then we've built an expertise around that. Going a step further into the intelligent type view is also integrating these models in standard workflow, standard work type approaches using optimization tools, for instance, using the PLM system also to that effect to automate certain tasks that may be repetitive. So at the end of the day, using all these tools, building those digital representations of our products, your products, within that platform, really deliver innovation at the end, right? So that's what really I wanted to achieve, is set the stage, define what the digital twin means for our world, and more importantly, set the stage for René where we'll rapidly turn to some practical examples. And again, the theme for today, guys, is great tools, great simulation tools, not just Siemens. There's a number of additional tools you may be using. Sorry, Siemens guys back there, but that's reality, right? So you want to start with that, but you also want good ingredients, best practices, training, mentoring, methodology development, and automation. And that's what we're going to talk about in terms of added value we can bring to your business.